Oh, there we go. So I don't know why. I'll let that download for a sec. Let me know if you guys can hear everything okay. Oh, I always hated the gut hurting. Yo, what's up, Newt? I figured I'd play some games for once. Take a little time to stream. This is my favorite game, by the way. I don't know if you have played this game before. It's such a good game. And now it's on PC because some people decompiled all the code. So, yeah, that's great. Also, let me know if the audio is okay. I'll probably do some coding stuff tonight in a little bit, but for now I'm just going to play for maybe 45 minutes. Alright, let me see if the texture pack is done. It's about halfway. Yeah, I played this on the Wii, I'm pretty sure, when I was younger, but I forgot about it. Yeah, I was on. I have it on. I grew up with it on the Wii as well. I played it on the GameCube as well, but I'd say I probably played the most of it on the Wii. It's such a good game. Like it's not like a lot of games where it's like necessarily perfect in any way, but it in my opinion, it's the best Zelda game. I mean, Tears of the Kingdom obviously is a better game objectively, but Twilight Princess is a better Zelda game. I mean, especially now since it's decompiled and everything. I mean, I can run it in 1440. It's running at 120 something frames right now. And on the original, you couldn't even with mods and stuff, you couldn't unlock the frame rate. So now that the frame rate is unlocked, it looks so much better. Some parts don't look as natural, but yeah. There's mods and stuff that are going to fix it. Also, I have a texture pack downloading, so it'll look way better once I download that. I got it working on my Mac, but I haven't... I'm on Linux right now, so... And there's a little menu, which I just need to give myself enough rupees to turn that on once and then not worry about it anymore. How does this run? Like, does it use an emulator and run a modified ISO file, or did they just completely port it to PC? So yeah, it doesn't. It's not emulated in any way. So basically, it's like you could literally get the GitHub source code right now and compile it in CMake. It's basically someone took the whole game, and now you can access any part of the code. And it's 100% decompiled, and they're still actively working on it. And it's like they added gyro controls. This is the GameCube version, so it is off of the GameCube version that was decompiled, which is objectively the better version. But they're actually working on, they are working on like decompiling or getting the Wii stuff to work as well as the Wii U version. So yeah, they basically reverse engineered the game on the GameCube, which is pretty impressive, you know. And yeah, they basically, you just have to provide your own copy of the game, which I have. And then it just runs like super, like, you can even see it has its own achievements now. Like, there's so much stuff that they added. Dang, people could use stuff from that code for inspiration for their own games. Yeah, I agree. Like, I think part of what I'm going to do in my own game eventually is use inspiration from this game, because it is my favorite game of all time. Like, I think this game has a lot that you could put in a game that would make it fun. I don't know. I don't know. Like, the combat doesn't have to be simple, but the art style is actually something I like, even though it hasn't aged as well. I mean, I'll show you what it looks like when I get the texture pack downloaded. Yeah. The start to Zelda games are always slow a little bit, which is fine. But now that I have like gyro aiming with my PS5 controller, it's so fun. I honestly would love to learn how to like do reverse engineering stuff, but it just coding it and everything there's a lot to learn every day. I'm sure there's still a huge fan base for these old art styles. Oh yeah, there totally is. There's a guy that is making his own game that basically just looks like this art style exactly, but he's building it in Unreal Engine 5, which is pretty cool. I mean, using modern hardware and game engines to build something old, I think is a good idea. I would say I don't really like Unreal in terms of, like, there are certain things about Unreal that I don't like, but that's not to say that it's bad in any way. Also, let me know if the audio is good. I definitely am going to do some C++ practice tonight. I think I really want to work on, like, abstract data types, and I want to kind of see what other options other than object-oriented programming are, because I think it'll be really important for me to look into different paradigms. The music from this game is probably my favorite part, to be honest, rather than the gameplay itself. The music itself is just so nostalgic. Unreal seems nice for a casual game dev, but very abstracted from the graphics side. Absolutely, yeah. I mean, looking at the stuff that we did with OpenGL, even like, I haven't even gotten that far. Like, some people can get through what I've gotten through in like a couple days. It's taken me probably a month to get to where I'm at, just because I'm a very slow learner and with certain things. Some things I like to rush. Not rush, but, you know, I like to be faster with, but, yeah, I mean, dude, Unreal is super extracted because you don't really, like with C++ and like OpenGL or Vulkan even, you can, oh yeah, like also look, they added Moonjump, which is really nice for getting some of these early chests, or not early chests, but like chests that take forever to get to later on. But yeah, Unreal is kind of abstracted in that way where it's like you can't really modify the internal data types and like objects. I mean, it's cool, I can just moon jump like this, you know? I don't really like I'm not gonna cheat through this playthrough as much. I mean, I'll probably use the moon jump to like do a few skips, but not like crazy skips. Like getting like the piece of hearts, you know? Oh yeah. Yeah, Tokyo Spliff has taken 10 years on his OpenGL project, so it definitely seems difficult. And I would say OpenGL is like the easiest graphics framework I've heard of. I mean, I don't know about SDL or DirectX or even Vulkan. I know Vulkan's really difficult. Like once you start getting into proprietary software for like Microsoft or Apple, it gets really tricky because then you have to like lean everything around. Like, you have to design everything in regard to that hardware, which is why it would be useful, like, if I wanted to use... Like, right now, my MacBook uses Metal for, like... If I was to play this on my MacBook, it would run in Metal, which Metal's gotten way better, you know? But, like, Tokyo Spliff, dude, I think I really liked a lot of his content because... First of all, he's kind of a unique guy, like... You run into his stream and it's like, who is this dude? Like, what is he doing? And then you realize he's like super good at what he does because he's put the time in to do it. And he doesn't just, I mean, my stance on AI is like, it can be such a good learning tool for getting information really fast. It's really bad at designing systems though. So, like, if I was to make my own game, I don't think I would use AI other than for, like, ideas and, like, like, maybe unit tests and stuff like that. Just, like, kind of mundane work that I would obviously check over as well. Tokyo Spliff said that at his workplace, he's the only graphics dev because they end up firing every new dev that joins because they aren't good. Yeah, dude. Well, dude is literally, like, his own company's AI agent. That's so freaking funny. So it's very gatekept. Yeah, absolutely. Like if I did it for 10 years, I'm sure I could get a job doing it, but I don't think I would ever do graphics programming as a career, just because it is so intense. Like, in comparison to regular C++ development, graphics programming is like a whole nother step because you're not only working with the CPU now, but you have the GPU, and, you know, a lot of stuff to worry about in that aspect. That's why a lot of people probably should use game engines. Like, I would use Godot probably for my game engine. But I want to also build my own game engine eventually because it's really good practice, and I think it would be amazing to, like, have a game that I've built from scratch, you know? I mean, even the solar system simulator that I built, I used a little bit of, like, help in terms of research, but, like, that solar system thing was all like mine, you know? Other than like looking up the calculations and all that, the math. It's very rewarding to like finish something even if it's not necessarily good. Just finishing work gets you one step further than someone who uses AI, you know? Someone dependent on AI is gonna always be one step behind, I think, in a lot of ways. Just depends on what you're doing, you know? Let me see if it's downloaded yet. Okay, it looks like it's almost downloaded, which is good. I gotta say, this is my least favorite part of the beginning of this game, just because, I don't know, the freaking goats get annoying. But it's really not too bad. Once you get past, I feel like the Forest Temple, it's incredible. Once you get past the Master Sword, it's even better. Because then you get City in the Sky, you get Snow Peak. Snow Peak's probably my favorite temple, to be honest, in this game. Though, that's a really hard... It's a hard... Snow Peak... Temple of Time's pretty cool. I think Temple of Time, the idea of it, is like such a cool... It's like the coolest idea for a temple. Like a dungeon. I don't necessarily think it's a good dungeon in the sense of, like, it's fun in the same way that some of the other ones are. I'm trying to think. What's the most fun dungeon? I would say... Oh, it looks like it finished. Okay, perfect. The most fun dungeon is probably Arbiter's Grounds, honestly. That one's pretty crazy. I like City in the Sky as well. City in the Sky is just super unique. They're all really unique. Alright, let's get this texture pack downloaded. I know I'm skipping a lot just because I want to get past the... Alright, let's see. So basically I just need to drag this. I need to go to Dusk. Open item location. Dusk, Twilight Princess, texture pack, Linux. Let's see. I don't know how I'm gonna get the texture pack working quite yet. I'll probably have to compile it on my own, which is fine. Okay, you know what I'll do? I think since I was just doing Twilight Princess for a good bit, maybe I'll switch to doing some programming. Just because I need to do some C++ practice for sure. I need to do OpenGL as well, so that's a good place to stop. I just need to change my title. Learning OpenGL and C++. 31. Come and study. Pomodoro 5010. Sorry guys, one sec. Alright, title should be updated. So, yeah, let's see. So last time we got our cube and our cubes drawn, so we need to work on, I believe it's the, what's it called? We did the ambient lighting, and now we need to do the diffuse lighting, which basic lighting. That's fine. This works. Okay, so we talked about how we have a normal vector that basically is perpendicular to the object, and then we're able to get the light ray fragment that once that hits it, we can get the angle, and then that angle basically lets us transform the light. So normal vectors. So our light ray is equal to our light fragment and position vector. Light and fragment position vector. That's what it is. Let me get my pen. Okay, so a normal vector is a unit vector, which, let's remind what a unit vector is. What is a unit vector? I'm not a robot. A unit vector is a vector with a magnitude and length of exactly 1. Okay, gotcha. So let me write that down. Okay, so that's right, because we also do use, in OpenGL, we use NDC, which is normalized device coordinates, which means that when we're rendering our scene, essentially, we have to normalize, like if we have our own coordinate system that goes above 1, we have to normalize that to fit within that calculation of 1, or that range of 1. It's -1 to 1. So a normal vector is a unit vector that is perpendicular to the surface of a vertex. Since a vertex by itself has no surface, it's just a single point in space, we retrieve a normal vector by using its surrounding vertices to figure out the surface of the vector. So we retrieve a normal vector. By using its surrounding vertices to figure out the surface of the vertex. Also, I'm gonna work on my my devlog, I believe. So I'm gonna probably do that tonight. I'll do a little bit if I have some ideas. Oh, I think I'll probably make like a few minute, like couple minute video just talking about here's what I'm learned about OpenGL and what I'm planning on, you know, working on, like working towards when it comes to like what's the future of my education in this area in graphics development. So yeah. Also, let me get the Pomodoro timer going. I totally forgot. If you guys are new, please feel free to study along with me. And if you have any feedback, as always, let me know. In fact, what I'll do is, gotta love windowing, man. There we go. Also, congrats on 300 subs. Hey, I appreciate it, man. Yeah, I feel like the channel's been growing a lot faster, and I really appreciate everybody just coming and hanging out. Mostly, honestly, it's really great to have such a great community growing. So yeah, thank you guys. There we go. And I wonder if I can even. No, that's fine. Whatever. Okay, so we retrieve a normal vector by using the surrounding vectors. We can use a little trick to calculate the normal vectors for all the cube's vertices by using the cross product. But since a 3D cube is not a complicated shape, we can simply manually add them to the vertex data. The updated vertex array can be found here. Try to visualize that the normals are indeed vectors perpendicular to each plane's surface. A cube consists of 6 planes. Okay. I will... Sorry, 1 second. I'm replying to a text. Alright, sorry guys. I was replying to a text. Okay, so basically, instead of using the cross product, since we would use a cross product for like different shapes, I'm assuming, A cube isn't complicated, so we can manually add the vertex data. So we can manually add normal vectors to cube vertex data. Okay, so and basically we can update our vertices here. So like what I did with my 2D game is I essentially created a circular, like I used, let me show you what I did. The nice thing, I think, once we get into more complex generation of objects, like I basically created a mesh class, like an object that draws our circle for us. So like our mesh generator basically takes a shared pointer, which takes a radius and the number of segments, which that will then draw a circle. So instead of having to input, I think once we get to a 3D object, we'll have like, you know, our X, Y, and Z coordinates, and we can probably kind of make some sort of mesh out of that we can generate multiple objects without having to completely, manually define them every time. But I'm excited for that because I would hate to have to like write all this just like from scratch. I don't know. I feel like that would be stupid. Like right now, it makes total sense, and I appreciate them providing that for us. Because before we just have our X, Y, and Z, which is our positions, and now we have our normal. We have three more, which is our not our texture or our. It's not our texture coordinates. It's our normal vectors. So that makes sense. Hello, dude. What distro do I use? I'm using CashOS, which is a Arch Linux distribution. It's a little bit more clean in my opinion, just for most stuff. I'm using GNOME for like my desktop environment, just because it's kind of similar to what I use on macOS, and I figured using something similar would make it easier right now. But yeah, I appreciate you dropping in the stream. Welcome to the stream. Induplinduppy, I think. I don't know how to say your name. Induplinduppy. I hope I said that right. I'm gonna just stop trying because I'll butcher it. Which I also will probably update that in future descriptions of like what my device, like my, I'll try and update what I use, like what I use for my PC and all that. Sorry, one sec, guys. Yo, this is literally peak. Hey, I appreciate it, man. Sorry, I'm texting my wife really quick. um, Marble Guy, welcome to the stream. Okay, back to what we were doing. So we need to try to visualize that the normals are indeed vectors perpendicular to each plane surface. So a cube consists of 6 planes. Yeah, so we have... Yeah, that makes sense. Okay. So since we added extra data to the vertex data, we need to update the cube's the shader, the fragment, or the vertex shader, which makes sense. Uh, yeah, this is literally peak. So what's the next part of this project? So this project is, I'm following through OpenGL's tutorials right now. So my goal with this is to learn, right now I'm learning about lighting in 3D environments. So we're basically looking at how to simulate light in using code and using math, and this is all in C++. If you guys are interested, I would say Learn OpenGL is a really good resource for this. Obviously, that's what I'm following. Let me put this in the chat. Learn OpenGL. Also, the Discord is... And if you guys are want to chat with me more and have questions, feel free to join the Discord. Trying to think what else. I don't know. Oh, also, I noticed we got to 311. Thank you guys for subbing. Why OpenGL? It's almost like deprecated. No, I totally know. The reason why I chose OpenGL is because it's kind of an introduction to graphics programming. So once I get into Vulkan, this will be a really good starting point to understanding basic graphics graphics fundamentals. And I think that jumping into Vulkan without knowing a lot of the stuff that you can learn here for easier, less time and knowledge, is definitely a better resource. Try Raylib, it's beginner friendly. Yeah, I think Raylib's great as well. I actually have used Raylib before in C# projects. I think that Raylib is a lot more abstracted because OpenGL, even though it's more deprecated, I think it's interesting and it's important to know, especially using models, views, projection matrices, learning shaders, fragment shaders, vertex shaders, shader classes, camera classes, all these different things that AI could do in seconds. Just learning about it is really an important thing, I think, for especially if you're going to make your own game engine. So yeah. So do you plan on learning Vulkan in the future? Yeah, I probably will. I think my goal is to probably jump into Vulkan after I get fully through these tutorials, as well as making my own project that's done, whether that be a game or just a simulation like I did with... for you guys that are new here, I just wrapped up the beginning parts of this solar system simulator. And I did this all from scratch in stream. So, and I'm actually going to work on a devlog as well. But this solar system simulator, obviously, I need to make a camera for it. It basically simulates the planets orbiting the sun, and I basically just used a lot of. I made a factory for. I used some design patterns. I used texture loaders. I used a camera. I'm working on the camera. That's my next steps for this project. But yeah, I just made all this from scratch. Kind of, it took a long time, but it was fun. I think it was worth it. I learned a lot. And I also drew all the sprites. I drew all the sprites, which I think I actually really think I did a good job on. This makes me optimistic for like future game development, you know? Like I think that if I ever want to make my own game, I know that I don't have to be a huge artist to make it look somewhat appealing. But yeah, that's kind of what I worked on. I worked on a lot of different things to optimize it. It's definitely not perfect, but I had a good time, and I will probably continue working on that later on. But yeah, anyways, I just figured it was a good entry-level OpenGL project. So, does the planets have gravity? Because if you have the planets close, make it. Yeah. So I didn't add I didn't add like dynamic physics to where it's like generating the gravity constant. Essentially what I did was I created a planet data JSON file where I could put the radius, the speed, the rotation speed, and I did have a physics class. Like I had a bunch of different physics classes where I'm planning on one of the next steps is actually what you're talking about, is adding a constant gravity that I can apply to all of the planets. So, yeah. But yeah, anyways, I hope that answers your questions. I'm happy to answer any more if you have any. Let's see. So how long have you been on Linux? I have been using Linux for about a year now. I completely quit Windows because, quite frankly, I just hate it. I use Mac OS for work mainly. If you guys are new to this channel, I just got a job as a full stack engineer that I'm starting next week. And I don't do much web development, to be honest, but I'm excited to, have a good job like that. But what was I saying? Gosh. Yeah, I've been using Linux for a while. I think that it's a really good platform, especially for developers. I recommend it over Windows, but yeah, that's just my take. Is it open source? Yeah, I mean, my project's on my GitHub. I don't think I have it in the description or anything, but I have it on my GitHub. SSLORL said nice, and Impossive and Posse, I don't even know. I'm just going to say Imposs says good job. I appreciate you guys being here. Thanks for the support, everybody. Also, I feel like the sub count went up a lot, so I appreciate you guys being here and watching the stream. Anyways, we need to update the vertex shader. That's where I was at. It's so fun having people in the stream, but man, I get distracted. If you guys have questions about how I do stuff, let me know. So basically, we need to now add our normal vector. So we would say that would be our location 1. Which we're inputting that, so that would be a normal. Now that we added a normal vector to each of the vertices and updated the vertex shader, we should update the vertex attribute pointers as well. Note that the light sources cube uses the same vertex array for its vertex data, but the lamp shader has no use of the newly added normal vectors. Since we don't have to update the lamp shaders or attribute configurations, but we at least have to modify the vertex attribute pointers to reflect the new vertex array size. Yeah, that makes sense. So we need to go down here, and since we have more than 3 now, so before we were using 3 positions essentially, so X, Y, and Z, think of it like that. Now we have 6 different vertex attributes to keep track of. So instead of saying 3 times the size of the float, we'll say 6, because we're using those 6 I guess what was the word for it? Let me find the word. It's like the range, essentially. Also, if you guys are new here, I do take all my notes on paper, just because it works better for me, and I think that it's a better way to learn. So, let's see. Man, I'm forgetting the name of the... It's essentially like a range of some sorts. Okay, let's see. Do I give out my GitHub? I do in the... Like, if you ask in the Discord, I'll give it. I'll let you see it, but not on stream, probably not. Do you ever use AI to learn or just documentation? Yeah, I totally use it to learn. I think that AI is a great tool to learn as long as you are using it intentionally and know what you're doing with it. Okay, guys, it's 3 a.m. I live in Moscow, so I gotta go sleep. Thanks for the stream and good luck in learning. Hey, I appreciate you being here. Have a good day. I'm just gonna call you Ind. Have a wonderful night. Get some sleep. Thank you for showing up to the stream. Be sure to join the Discord if you want to stick around or ask questions for sure. It's gonna bug me if I don't know what the name of this is. Yeah, this is gonna drive me nuts. Span of vertex data called... I don't know if it's span or the stride. The stride. There we go. I was having such a hard time. So we have a stride of 6 now, since we have 6 different vertex attributes. So I don't know why I couldn't think of it. Oh, here we go. Okay, so in my notebook we have our vertex 1, which has XYZ, vertex 2, XYZ, vertex 3, XYZ. This range of 0 to 4, 8 to 12, that's in bytes. So basically each block on here takes up 1 byte, and we have a stride of 12 here, essentially, because we have 3 times... oh wait, let me see. Yeah, we have 4, 8, 12, so basically, because each block takes up 4 bytes, and 4 times 3 is 12. I hope that makes sense. I know you guys probably can't see that, but yeah. Also, I am working on a devlog. I haven't done much, any videos. I started making a video on AI and why we should learn by hand with AI, even though AI is around, why we should still learn things from scratch. And I probably will continue doing that, but I've been so busy. So yeah. Okay, so now we updated that. Let's try making this. I use make for everything here. And now, yeah, we can see here everything's working in our 3. So before I showed you guys my 2D environment, this is a 3D environment that we're simulating. Basically, we're keeping track of each plane, and our camera uses a kind of like a cone-shaped view. It's really interesting how it all works. It uses planes to then pick up everything. We're basically going to get to a point where right now we have ambient lighting, so we can't really tell, but the cube is actually being lit just by light in the area. And this cube will point a ray at the cube, and we'll get to see it lit up. It doesn't feel good using AI to make anything without understanding anything. Absolutely. Yeah, I think AI is such a crutch that you could fall into using. And if you use it incorrectly, you're just going to not know what you're doing at all, and that is not helpful to anybody, including yourself. Unless you're not an engineer. I don't know. It just depends. And also, I didn't even realize it says stride right here. We only want to use the first 3 floats of each vertex and ignore the last 3 floats, so we need to update the stride parameter to 6 times the size of the float, and then we're done. Okay. It may look inefficient using vertex data that is not being used by the lamp shader, but the vertex data is already stored in the GPU's memory from the container object, so we don't have to store new data in the GPU's memory. This actually makes it more efficient compared to allocating a new VBO specifically for the lamp. That makes sense. All the lighting calculations are done in the fragment shader, so we need to forward the normal vectors from the vertex shader to the fragment shader. Let's do that. So we need to go to our vertex shader, and we need to say normal, and then we also need to make this an output. So we are basically going to output that, and then inside of our fragment shader we will have an input variable, which we can just call normal. Now we need to calculate the diffuse color. We now have the normal vector for each vertex, but we still need the light's position vector and the fragment's position vector. Since the light's position is a single static variable, we can declare it as a uniform in the fragment shader. Okay, so I believe we'll do that inside of our light fragment. So I could be wrong, but that's fine. We'll just start here. Uniform vec3, and a vec3 is basically a vector object that has it stores x, y, and z essentially. If we had a vec4, that would also contain the alpha value. But right now we're just tracking vertex data. So, and then this would be our light position, and then update the uniform in the render loop or outside, since it doesn't change per frame. Since we use the light position vector declared in the previous chapter as the location of the diffuse light source. Okay, so we can actually just do that right outside the render loop. We can go right here, and we can just say like update the uniform for the light shader, and then we could just say lighting shader dot set vec3, and then we have our name of the position basically, and then we just set it here as well. Okay, that works great. And then the last thing we need is the actual fragment's position. We're going to do all the lighting calculations in world space, so we want a vertex position that is in world space first. Okay, so we need that is the actual fragment's position. So also, I just realized I don't even have any music. Not gonna lie, though, after reminding AI not to give me code first, and it ends up doing it anyways, shows that AI has some work to do with context. Absolutely, yeah. That's one of the things that I do when I have a new project, is I'll be like, you are basically a teacher, you're not supposed to give me the code unless I absolutely can't figure it out. Like, I'll go through everything first before I have it give me any solutions. So yeah. Either that, or it's learned from data that people love rebelling, so it's also rebelling as a choice. Yeah. It's using imperfect people to make imperfect data, essentially. There's no such thing as perfect AI. So we need the fragment's position. We're going to do all the lighting calculations in world space. So lighting calculations. So if you guys don't remember, with OpenGL we have different spaces where things are calculated. So world space would be in a different. Let me try and find the page for this. We basically have projection that allows us to calculate certain spaces. So our projection matrix basically is a set of vertex coordinates, which then we transform. We take our local coordinates, so let's say our coordinates to our vertex object, which is then relative to its local origin. It's basically where the object begins. And then we'll basically transform that into world coordinates, which are just respectful to the larger world. So like, think of our 3D environment, like our world coordinates are basically like it existing inside of this massive empty world that we created. And then we could transform those world coordinates into view space coordinates, which basically say, okay, we have all these objects that exist and like we can do stuff with them, but in order to make them visible to us, we need to put them in a locked position essentially. So a view space coordinate basically makes it so that we can see it from the camera. Like we can know that the data is there in world space, but we have to make sure we can see it through view space. And then basically project view space coordinates makes it so when that would be the last step, is where we can see in this window, whatever we see on the screen is in our view space, our project view space. So anything to the left or right of the cube that we can't see off screen is just in world space. So there's a lot of different steps in translating our coordinates to be visible to the player or the user that take a lot of different steps, and it's a lot of math. So anyways, I'm done explaining that. So basically what we need to do, we can accomplish this by multiplying the vertex position attribute with the model matrix only, not the view and projection matrix, to transform it to world space coordinates. This can be easily accomplished in the vertex shader, so let's declare an output variable and calculate its world space coordinates. Okay, so let's go to our vertex. I find that learning something new with AI wastes more time than reading the actual documentation. If you know how to navigate your way around docs, it's definitely superior. Yeah, no, totally. Not to get too sidetracked, but when I was doing this interview for the job that I got accepted to, one of the things they watched to see is if I actually went to official documentation instead of AI, because I wasn't really allowed to use AI, and that was a big part of the interview at least. And seeing me go to official documentation and be like, okay, here's how to use the use state in React or whatever, like looking up the syntax for it, that was definitely more helpful than being like, hey Claude, give me an answer to something that I don't know where you got the answer from, or whatever AI you use, ChatGPT or whatever. So yeah, I totally agree with that. I think there's documentation for a reason, and like people put a lot of time to make it somewhat understandable. Okay, anyways, so we have our normal going out. We also need to basically set our fragment position, so which is going to be our light ray that is going to be simulating our light. So we'll have our out vec3, and this will be our frag position, which I guess we have it above here, so I'll do that too. Frag position, and then basically we need to do frag position is equal to our world space. This is where we'll define our world space. So model times vec4, which takes our model projection, essentially. We have our model view and projection, but our model is the actual model itself. So vec3 times model and then vec4, and then that takes our position, and then our alpha value, which is 1.0. So that's basically like the opacity value. And then, yeah, and then lastly, add the corresponding input variable in the fragment shader. So that's where we will do input vec3 frag position. Let me see. Claude made many mistakes when I was writing my CPU emulator. I would talk with Claude about design choices or some concept, but for architecture specifications, it got things wrong more often than not. So I had to use the docs. Yeah, totally. I mean, AI only knows as much as like it doesn't. I wouldn't even say it knows as much of an engineer, as much as an engineer. It's more of like an information black hole. So it's basically just gonna give you whatever it can find, even if that's correct or not. You know, it's essentially just an algorithm that will give you an output based on your input. You know, that's kind of what it is. That's what algorithms are. You know, you have inputs and outputs, and it's basically just doing a lot of calculation to give you whatever it thinks the most correct result is. So, which, if you want the most correct result according to what is available, you got to go to documentation. So yeah. Anyways, this in variable will be interpolated from the 3 world position vectors of the triangle to form the frag position vector that is in the per fragment world position. Now that all the required variables are set, we can start the lighting calculations. Okay, so the first thing we need to calculate is the direction vector between the light source and the fragment's position. From the previous section, we know that the light's direction vector is a difference vector between the light's position vector and the fragment's position vector. As you might remember in the transformations chapter, we can easily calculate this difference by subtracting both vectors from each other. We also want to make sure that all the relevant vectors end up as unit vectors, so we normalize both the vector and the resulting direction vector. Okay, so many times I would say I'm wrong at the beginning and then write out a response, and at the end it changes its mind and says it was right all along. Kind of funny to see that. Yeah, that's what hallucination is. I mean, it basically, AI is not designed to give you it's designed to give you whatever you want to hear, essentially, and that's a right answer in its opinion. So it looks like we'll probably have to do this right here. Maybe. Vec3. I'm wondering, is that in Vec3 norm, normalize normal? I'm wondering if this is in our normal vector. Let's see. Normalize. If anyone here is watching, I'm wondering if I do this in the vertex shader or the fragment. I'm going to try just the fragment for now. I'm not sure. Would normalizing go in vector or vertex shader or fragment shader for for light direction? Normalization should be formed in the vertex shader. Gotcha. Okay, that makes sense. So vertex shader. Okay, yeah, that makes sense, I guess, because we do have frag position defined here. When calculating lighting, we do not care about the magnitude of a vector or their position. We only care about their direction. Because we only care about the direction, almost all calculations are done with unit vectors. Since it simplifies most calculations, like the dot product. So when doing lighting calculations, make sure to always normalize the relevant vectors to ensure they're actual unit vectors. Forgetting to normalize a vector is a popular mistake. So make sure to normalize vectors. That makes sense. Okay, so we need to calculate the diffuse impact of the light on the current fragment by taking the dot product between the norm and the light direction vectors. The resulting value is then multiplied with the light's color to get the diffuse component, resulting in darker diffuse component the greater the angle between both the vectors. Okay, so we take our dot product, and then we take our norm and light direction. You know, a lot of this stuff you kind of just can't fully understand, and that's okay. Diffuse, which is then equal to our difference times our light color, which is us multiplying those two together. So we're basically normalizing it and then multiplying them together. If the angle between both vectors is greater than 90 degrees, then the result of the dot product will actually become negative, and we'll end up with a negative diffuse component. For that reason, we use the max function. So use max function that returns the highest of both of its parameters to make sure that the diffuse component never becomes negative. Make sure diffuse component never becomes negative. Lighting for negative colors is not really defined, so it's best to stay away from that unless you're one of those eccentric artists. Now that you have both an ambient and diffuse component, we add both colors together or to each other and then multiply the result with the color of the object to get the resulting fragment's output color. So I hope I'm right in doing this. Vec3 result equals ambient plus diffuse times object color. I'm probably wrong here, but that's okay. Frag color is then equal to vec4, which then is equal to the result, and then 1.0. OpenGL tutorial seems very dense. It's a little dense, but you know that you sometimes want it to be dense, you know. Okay, that didn't work. I'm wondering what I did wrong here. Oh, here we go. Vertex shader. Fragment shader. and then vertex shader is thought it was the same one, so fragment shader for our light. Okay, let's try that now. Nope, that still is not working. I'm wondering if it's because we need to have a light cube vertex shader. I'll fix it. Don't worry, guys. Oh gosh, I did this stupid thing again. Why am I doing this? Alright, let's see. Vertex, light vertex.glsl. Okay, maybe that'll work. Okay, now it's just not working. Okay, let's copy this. Make sure it's all correct. Should be. Oh yeah, there we go. Okay, so I'm guessing let's look at what we had done here. So okay, I think I'm seeing it now. Okay. Yeah, so we had to do another vertex shader, which I feel like that was definitely I didn't really quite understand that, but we can see now we have lighting on. Our light is basically up here, but it's invisible now, and it's pointed right here, so it diffuses, which is awesome. Let's close all this. I definitely did something wrong because we can see our light is not showing up. Anyways, I'm going to stop there for tonight. I got to go. Thank you guys for being here. I appreciate you guys for the support and all the new subscribers. Thank you guys for being here. Feel free to subscribe and join the Discord. It is in the chat as well as in the description. Also please join the next stream. I should be streaming tomorrow. I'm going to work on my devlog a little bit and try and get something made for by the end of the week. I'm going to probably also go through and fix this, so I'll just say got diffuse and what was the other name? Diffused and hey, you too, thank you. You have a wonderful day. And ambient, that's what it is. Ambient waiting. Done. Alright. Look at that. We're 35 seconds short of the Pomodoro. So, thank you guys for being here. I will be back tomorrow. Join the Discord and feel free to sub if you guys are new. Have a wonderful night. I will talk to you guys later.